Welcome to week 6, and this is an example for problem number 5. A certain tennis player makes a successful serve 82% of the time, assuming that each serve is independent of the other. If she serves 7 times, what is the probability that she gets? In the first case, we want to find 7 serves in, and that would be a hell of a match. Or in part B, we want to look at exactly 5 serves in, and in part C we're looking at least 5 serves in. So this requires some amount of interpretation, and I'm gonna go ahead and use PHstat2, which I have here, add-ins and PHstat, and there's a video that shows you how to load that. We are doing a binomial distribution. This problem is pretty similar to number 2. So if you haven't looked at the video for number 2, you want to take a look at it. It goes beyond the solution for that problem and has some principles. The sample size in this case is 7. Probability of interest is 0.82. And I'm interested in outcomes from 0 to the 7 successful outcomes. And let's go ahead and name that 0 to 7. And I want to see the cumulative probabilities, so I'm going to hit cumulative, and then I will hit OK. Once you hit OK, then you end up with this table here, and we want to interpret what we're being asked for. In part A, we want to see if all 7 serves are in. So the sample size is 7, the probability is 0.82. We want to see if exactly 7, so we're looking at px, not p less than or equal to x or anything else. We're looking at exactly 7, so this is going to be the answer to part A of the problem, 0.0249285, and again you want to round this down to the specified number of decimal points, and you can use this until you are comfortable doing it by visual inspection, which is pretty straightforward. Part B, we are being asked to come up with what if exactly 5 serves are in. So that is going to be equal to probability of exactly 5 is going to be equal to right there, which is showing px, and x is 5. So this is going to be 0.25281. Now the next thing that we have to do is asking us to find that is at least 5 serves. Now at least 5 serves, if we're doing 7 serves, we could have 7 successes, 6, 5, and we could continue that down to as little as 0 successes. So in looking and trying to examine what does it mean to have at least 5 serves in, is it going to include the probability of a 7 serve? The answer is yes. Is it going to include the probability of probably getting only 6? The answer is yes. And it says at least 5, so it's also going to include that. Will it include the probability of 4? No, it won't. 3? No, it won't. 2? No, it won't. So what we're going to look at is we can actually, for the probability of at least 5, if we know the probability of exactly 5, probability of exactly 6, and the probability of exactly 7, we can add these 3. So for part C, our response is the probability of exactly 7 plus probability of exactly 6 plus probability of exactly 5. These 3 parameters here are exactly what we're looking for here, because we are interested in the probability of the probability of at least 5. And for that to happen, it needs to be 5, or it could be 6, or it could be 7. So if we look at the probability of exactly 5, exactly 6, and exactly 7, and we add these together, then voila, you would have the answer to part C. Alright, so feel free to reach out to us if you have any questions. Again, this table is pretty powerful. You have to think through what is being asked to know where to pull the information from. And then once you have that, you should be golden. Alright, thank you for watching.